Hello everyone, welcome to this video lesson. In this video lesson, we are going to solve a problem based on one-dimensional motion. Let us first try identifying what is given in the problem. It is given in the problem that there is a scooter. It can produce a maximum acceleration, means change in velocity in a positive way is 5 meter per second square. And it can, by applying the brakes, can produce a maximum retardation of 10 meter per second square. This is the way how it is going to reduce. We need to know the minimum time required to cover a distance of 1.5 kilometer or 1500 meters. So it is very clear that the body has to start from a state of rest, obviously, because initial velocity is nothing mentioned about it. So then it will accelerate for a certain time. Say it is accelerating for a time t1. Then it will acquire a velocity v1. It will accelerate with a maximum value v1 alpha and then acquire a maximum velocity v1. Then it starts retarding with the value given for u beta 10 meter per second square. Finally, that again comes to the state of rest. That for the second phase it has taken a time t2. Therefore, it has started from the rest, acquired a maximum velocity v1 and again come to the state of rest during the time interval t2. So I need to solve this problem as two phases. This is phase 1 and this is phase 2. I can say in phase 1, between the 2 points where it has covered a distance, say for example for a time t1, I can use the relation v square minus u square is nothing but equal to 2as. V square minus u square is nothing but equal to 2as. Let the distance covered in the first part is s1, so I can call it like a s1. The velocity that let it has acquired at the maximum value is v itself, because there is no other v. V square minus, starting from the state of rest, 0 square to acceleration he has given in the problem as 5 meter per second square, and it has covered a distance of something like s1. From this I can say s1 is nothing but equal to v square by 10. That's all in phase 1. Then we can go for phase 2. See what is given in phase 2. It is starting with maximum velocity v and finally coming to the state of rest by using the same formula, v square minus c square equal to 2as. Finally coming to the state of rest. It is not starting with a velocity u. It is here now. It is starting with a velocity v. 2. It is retardation. That's why it is stopping. So the value is minus 10. Because it's retardation, I have written a minus 10. Let this distance covered here is nothing but equal to s2. That implies I can get a value of s2 as v square by 20 by rearranging the terms. So if I want to calculate what is the total distance traveled by the body, I can say, as I want to calculate the total distance traveled by the body, in the first phase it has covered a distance s1. In the second phase it has covered a distance s2. So I can say total distance is simply s1 plus s2. Total distance is given for you as 1.5 kilometer or 1500 meters. S1 plus S2 as we have calculated is v square by 10 plus v square by 20. That's nothing but equal to, taking 20 as LCM, 2v square plus v square. That's nothing but equal to 3v square by 20 is 1500. So I can write 3v square is 1500 into 20. It's nothing but equal to 1500 into 2 will be 3000, and the 20, that is 3000. That is 3v square. So v square will be nothing but equal to 10,000. So v is square root of that. That is nothing but equal to 100 meter per second. So it is very clear that this body is going to get a maximum velocity of 100 meter per second. Once if I know the value of that maximum velocity, again I can go back to phase 1. In phase 1, it has started from the state of rest. Here, acquired a velocity v. I would like to write a formula v equal to u plus at. We have just now calculated that value v. Let me assume that the time taken is t1. V is nothing but equal to 100, starting from the state of rest. A is 5, given in the problem. Time taken is t1. So t1 will be nothing but equal to 100 by 5. That's nothing but equal to 20 seconds. Now there is phase 2. In phase 2 again, I can write a similar kind of equation. V equal to u plus at. By substituting that data, v 0, u nothing but v maximum, a is nothing but minus 10 because it's retardation, time is t2. We have already calculated. That implies 100 equal to 10 t2. T2 is nothing but equal to 10 seconds. Now you want the total time. So I can say the total time for which the journey happened is 20 seconds in the first part and the 10 seconds in the second part. Together it is going to take a time of 30 seconds. That's how we need to solve the problem. So we can say to cover a distance of 1.5 kilometer, it is going to take a time of 30 seconds. Thank you for watching.